Dear students, welcome to my classroom. In previous class, we learned how to plot the points in coordinate plane and the derivation of the formula using in the using in finding the distance between 2 points in a plane, as well as we solved some problems in exercise 7.1 based on the distance formula. Okay, and in this class, we are going to solve some more problems in exercise 7.1 based on the distance formula. Third problem, verify whether the points 1, 5, 2, 3 and -2, -1 are collinear or not. So first we have to name the points with alphabets. So let the given points be A 1, 5, B 2, 3 and C -2, -1. Now we have to verify that whether these points are collinear or not. So please consider 3 points P, Q, R. If these 3 points are not collinear, then we can draw a triangle joining these 3 points. And we know that in a triangle, sum of two sides is greater than third side. So here PQ plus PR must be greater than QR. But if P lies on QR like this, that is PQ and R are collinear points, then PQ plus PR is equal to QR here, isn't it? So among the distances between the points taken to at a time, sum of two distances must be equal to third side. Then only the 3 points are collinear. Okay, so now we have to find the distances between AB and BC and CA. Among these 3 distances, if sum of two distances is equal to third distance, then only these 3 points are collinear. Okay, like this, PQ plus PR is equal to QR. So now find the distance AB, that is length of AB. And we know that the distance formula is under root x2 minus x1 whole square plus y2 minus y1 whole square. So now take A and B and use the distance formula. Then x2 minus x1, that is 2 minus 1 whole square plus y2 minus y1 whole square is 3 minus 5 whole square. So simplifying this one, we get root 5 units. And now find the length of BC. Length of BC is -2 whole square plus -1 -3 whole square. So the length of BC is equal to root 32 units. And now length of AC. Length of AC is equal to under root -2 -1 whole square plus -1 -5 whole square. And that one is equal to under root -3 whole square plus -6 whole square, which is equal to root 45 and can be written as 3 root 5 units. Now, here the distances are root 5, root 32 and root 45. And we can notice that here AB plus BC not is equal to AC. Because AB is equal to root 5, BC is equal to root 32 and AC is equal to 3 root 5. And AB plus BC, that is root 5 plus root 32, not is equal to 3 root 5. So AB plus BC is not equal to AC, so that the given points are not collinear. Okay. And now before going to some more problems, we must recapitulate some points regarding to geometrical figures. So in isosceles triangle, we know that among the 3 sides, 2 sides are equal. And in this particular triangle, we have AB is equal to AC. And in an equilateral triangle, 3 sides are equal. If PQR is an equilateral triangle, then PQ is equal to QR is equal to PR. And if XYZ is an sorry, it is not equilateral triangle. Here XYZ is right angle triangle. So if XYZ is a right angle triangle with angle Y is equal to 90 degrees, then the square of the hypotenuse, that is XZ square, is equal to XY square plus YZ square, which is the Pythagoras theorem. And if ABCD is a parallelogram, we know that opposite sides are equal. That is AB is equal to CD and AD is equal to BC. And if ABCD is a rectangle, we know that opposite sides are equal as well as the diagonals are equal. That is AB is equal to CD, AD is equal to BC, and AC equal to BD. And if ABCD is a rhombus, we know that all sides are equal. That is AB is equal to BC is equal to CD is equal to AD. And if ABCD is a square, all sides are equal as well as diagonals are equal. That is AB is equal to BC is equal to CD is equal to AD and AC is equal to BD. Okay. Now, let's start the problems in exercise 7.1. Check whether 5 comma minus 2, 6 comma 4 and 7 comma minus 2 are the vertices of an isosceles triangle. So first we have to name the given points with alphabets. So let the given points be A 5 comma minus 2, B 6 comma 4 and C 7 comma minus 2. Now the length of AB. To prove that ABC is an isosceles triangle, we have to show that lengths of among the lengths of AB, BC and AC, two lengths must be equal. So find length of AB, which is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. So 6 minus 5 whole square, 4 minus half minus 2, that is 4 plus 2 whole square. So from this we get AB is equal to root 37 units. And length of BC, that is under root 7 minus 6 whole square plus minus 2 minus 4 whole square, that is root 1 square plus minus 6 whole square. So which is equal to root 37 units. As well as length of AC is equal to, we get 2 units. So among these lengths AB, BC and AC, we got that AB is equal to BC because both AB and BC are is equal to root 37 units. So given points form an isosceles triangle. So given points are the vertices of an isosceles triangle. Okay. So next problem. In a classroom, 4 friends are seated at the points A, B, C and D as shown in figure. Zarina and Funny walk into the class, and after observing for a few minutes, Zarina asks Funny, "Don't you notice that ABCD is a square?" Funny disagrees. Using distance formula, decide who is correct and why. So here it is the figure. A, B, C and D are 4 friends which are seated like this. So here the coordinates of A, B and C, D are: A is 3, 4 and B is 6, 7, C is 9, 4 and D is 6, 1. These are the coordinates of A, B, C and D. So to find that who is correct, we have to verify that whether ABCD is a square or not. So if ABCD is a square, we know that all sides, that is AB, BC, CD and AD are equal, as well as the diagonals AC and BD also equal. So let us check whether these are the vertices of a square or not. So first, length of AB. And length of AB is under root 7 minus 4 whole square, under root 6 minus 3 whole square plus 7 minus 4 whole square. So we get root 80. And after that, length of BC. So length of BC is 9 minus 6 whole square plus 4 minus 7 whole square under root. So from that we get BC also root 18. And now length of CD. Length of CD is under root 6 minus 9 whole square plus 1 minus 4 whole square. So again we get root 18. And now the length of AD. The length of AD is under root 6 minus 3 whole square plus 1 minus 4 whole square, which is equal to 18 again. So all the four sides of ABCD are equal. Now we have to check that whether diagonals are equal or not. So take the first diagonal AC, length of AC. Length of AC is 9 minus 3 under root 9 minus 3 whole square plus 4 minus 4 whole square. So that is 6 units. And now length of BD. And length of BD is equal to under root 6 minus 6 whole square plus 1 minus 7 whole square. That is root 0 plus 36, which is equal to 6. So we get that the lengths of diagonals are also equal. So here AB is equal to BC is equal to CD is equal to AD and AC equal to BD. That is all sides are equal as well as diagonals are equal. Therefore, ABCD is a square. So among Zerina and Funny, Zerina is correct. Okay. So the argument of Zerina is correct. So next problem. Show that the following points form an equilateral triangle. And the points are given that A comma 0, B minus A comma 0, and C 0 comma A root 3. So to show that ABC is an equilateral triangle, we have to show that all the sides are equal. That is AB is equal to BC is equal to AC. So first the given points are A comma 0, B minus A comma 0, and C 0 comma A root 3. Now the length of AB is, the formula is under root x2 minus x1 whole square plus y2 minus y1 whole square, which is already we know. And substituting the values of x1, y1 and x2, y2, we get minus a whole square plus 0 minus 0 whole square. So in that way, we get AB is equal to 2a. And length of BC. Length of BC is 0 minus half minus a whole square plus a root 3 minus 0 whole square. So from that we get BC also is equal to 2a. Now length of AC. Length of AC is 0 minus a whole square plus a root 3 minus 0 whole square. So we get that the side AC is also equal to 2a. So now we got AB is equal to BC is equal to CA, so that the given triangle is an equilateral triangle. That is, points A, B, and C form an equilateral triangle. Okay. And now next problem. Prove that the points minus 7 comma minus 3, 5 comma 10, 15 comma 8, and 3 comma minus 5 taken in order are the corners of a parallelogram. That is, these are the vertices of a parallelogram. Okay. So let the given points be A, B, C, and D. To show that ABCD is a parallelogram, we have to show that opposite sides are equal, as well as, oh sorry, that's all. Opposite sides are equal. That is, AB is equal to CD and AD is equal to BC. So now first find length of AB. And length of AB is equal to 5 minus half minus 7 whole square plus 10 minus half minus 3 whole square. That is 5 plus 7 whole square plus 10 plus 3 whole square, which is equal to under root 12 square plus 13 square, and is equal to root 144 plus 169 is equal to root 313 units. And now length of BC. And length of BC is equal to under root 15 minus 5 whole square plus 8 minus 10 whole square. So which is equal to under root 10 square plus minus 2 whole square and is equal to root 104. Now length of CD. CD is under root 15 minus 3 minus 15 whole square plus minus 5 minus 8 whole square. That is under root minus 12 whole square plus minus 13 whole square, which is equal to root 313 units. Again, length of AD. Length of AD is equal to, as usually, we get root 104 units. And we can observe that AB is equal to CD and length of BC is equal to length of AD. So the given points form a parallelogram. Okay. Now the next problem. Show that the points minus 4 comma minus 7, minus 1 comma 2, 8 comma 5 and 5 comma minus 4 taken in order are the vertices of a rhombus. Find its area. So here we have to show that the given points form a rhombus as well as we have to find its area. Okay. So let us name the points A, B, C and D. So first length of AB. Length of AB is, we get root 90 units, and length of BC is also root 90 units. Length of ACD is also is equal to root 90 units, and length of AD is also root 90 units. So that is all sides of given figure are equal. Therefore, so first here length of AC is equal to root 144 plus 144 root 288 units, that is 12 root 2, and length of BD is root 72, that is 6 root 2 units. So here we get all the sides are equal but diagonals are not equal. Therefore, given points form a rhombus. Now its area is equal to, we know that the area of rhombus is equal to half into product of the diagonals. That is half into AC into BD. So half into, here AC is the length of first diagonal 12 root 2 and BD is the length of second diagonal 6 root 2. So from this we get 12 into 6 by 12 into 6 72 and root 2 into root 2 2 by 2. So which is equal to 72 square units. Therefore, so in this way we can show that the given points form a rhombus and also we can find its area. Okay. Now name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. So under this title, we have first question minus 1 comma minus 2, 1 comma 0, minus 1 comma 2 and minus 3 comma 0. Okay. So let the given points be A, B, C and D. So to check that which type of quadrilateral is formed, we have to find the lengths and lengths of sides as well as lengths of diagonals. Okay. So first length of AB is under root x2 minus x1 whole square plus y2 minus y1 whole square, which is equal to root 8 units. And length of BC is equal to under root minus 1 whole square plus 2 minus 0 whole square, which is equal to root 8 units. As well as length of CD is equal to root 8 units. And length of AD is equal to also root 8 units. And now length of the diagonals. Length of AC is equal to root 16, that is 4 units. And length of BD is equal to root 16, which is equal to 4 units. So here we got all the sides equal and two diagonals are equal. That is AB is equal to BC equal to CD is equal to AD, as well as AC is equal to BD. So that is all sides are equal and diagonals are equal. Hence given points form a square. Okay. Next, second one is minus 3 comma 5, 3 comma 1, 1 comma minus 3, minus 5 comma 1. So let the given points be A, B, C, and D. And the length of AB is equal to root 52 units. And length of BC is equal to root 20 units. Length of CD is equal to root 52 units. Length of AD is equal to root 20 units. Opposite sides are equal. And now let us check diagonals. Length of AC is equal to root 80 units and length of BD is equal to 8 units. So that is here the lengths of diagonals are not equal. Opposite sides are equal and diagonals are not equal. So the given points form a parallelogram. Here it is all sides are equal, but it is wrong. Only opposite sides are equal. Okay, please correct this one. And next third one 4, 5, 7, 6, 4, 3, 1, 2. So let the given points be A, B, C, and D. Again, AB is equal to root 10, BC is equal to root 18, CD is equal to root 10, AD is equal to root 18, and AC is equal to root 4, that is 2, and BD is equal to root 52. That is AB is equal to CD and BC is equal to AD and AC not equal to BD. So all sides are equal. No, not all sides are equal. Only opposite sides are equal here also. And diagonals are not equal. Hence given points form a parallelogram. Okay, students, that's all for today. And in next class, we shall solve some more problems in this exercise. Until then, see you. Bye.